Hello everybody and welcome to Genesis Customer Care Tech tutorial. Today we have Michael Cook from Voice Self-Service team presenting Troubleshooting Virtual Hold, overview of changes in Virtual Hold 8.x architecture and basic troubleshooting methodologies. Also we have Surrender T from the same team to answer your chat questions during the session. There are a few logistics you should know before we get started. The session will be recorded and posted to Tech Tutorial page of the Customer Care website in a week. You will receive an email with the recording link when it's available. Phone lines will be muted until Q&A session at the end of the presentation. If you need clarification about the material during the session, you can type your question into the chat window and we'll answer those questions, unless it would be better answered during the Q&A session at the end. When you exit the webinar, a brief survey will be displayed in your web browser. Thank you for taking a minute to complete the survey. Genesis uses this feedback to improve our tech tutorials. And now I am turning the session over to Michael.
Thank you. Good morning or good afternoon, depending on where you are. My name is Michael Cook. I work in Genesis Customer Care, supporting voice self-service. Today I'm presenting you an overview of the major changes with the release of Virtual Hold version 8. I'll provide a bit of review for the 7.x core components, what changes have been made to the Virtual Hold architecture, and how 7.x components now work with the newly added features that have been released in the 8.x platform. I'll be reviewing how Virtual Hold integrates with Genesis, along with a high-level overview of both inbound and outbound call flows. Nothing really has changed much in how Virtual Hold integrates with Genesis or the traditional call flow from version 7.x to 8.x. However, these are largely used when troubleshooting issues with Virtual Hold. Lastly, I'll be covering a bit of log collection, where to locate logs and archives, as well as SQL queries to assist in troubleshooting issues. Here we'll be covering the major changes between Virtual Hold 7.x and 8.x, with a bit of review of previous components and functionality. Version 7.x components are designed to run as Windows services. These services run executable processes that are located in the Virtual Hold technology installation directory. When running, each component can be seen in Services applet with the started state and in Task Manager as a running process. Each component is identified with a VHT prefix. Here's a view of both NT services and processes viewed in Task Manager 7.x deployment of Virtual Hold. As you can see, there is a one-to-one relationship between each process and its corresponding NT service. Each VHT component performs tasks essential to the Virtual Hold's functionality. Queue Manager receives route requests from the PBX or ACD and processes call statistics and user data. In return, Queue Manager then sends the route responses that are used to control the routing of a call. Sense stands for System Event Notification Service. Sense uses Windows Management Instrumentation to monitor and control Virtual Hold and other critical Windows services to ensure that they are operational. Operational Mode Server. Op Mode Server is a service that controls the operational mode changes that are updated via IQ. This includes schedule op modes and holiday schedules. The common operation modes used are normal, queue speak, standby, and purge. Report Writer is a service that updates the VHT RTP database. It does this by scrubbing the archive database and pulling information specific to each call. The QWatch client is a service that runs in QInfo server hosted by IIS. Its responsibility is to take real-time data from Queue Manager and write this to a file to be used by the VHQ Watch web service. Web services use web connections to process and distribute data amongst IQ, Queue Manager, and databases. These web services can be viewed via IIS Manager as seen here. The provider service is a service that runs locally on the Queue Manager server and is a go-between from Queue Manager and the main web service, VHQ MWS. VirtualHold still utilizes much of the 7.x components such as queue manager, operational mode, server, etc. However, much has changed in the core architecture, and new features have been added to improve upon the platform's redundancy and optimization. 8.x releases of VirtualHold no longer have a one-to-one relationship between VirtualHold services and the processes which they initiate. Multiple processes are now controlled by a single service. Functionality has been added to VirtualHold 8.x that allows Erlang programming language to operate within the Windows environment. This provides that ability to synchronize data using Amnesia distributed data store technology. Notification, server, and management API features have also been added to the version 8.x release, which works in tandem with the Amnesia database or data store, providing synchronization of component and their status. Here's a view of the NT services and task manager reflecting the new VirtualHold architecture provided in 8.x release. As you can see, there are some new components that are initialized by the new set of services and some consolidation of processes within a single executable. One of these new features is called Core Monitor. Core Monitor can be deployed for both standalone and HA solutions, and it provides an automatic failover between two queue managers. The Core Monitor controls and monitors version 7.x components and prevents unplanned downtime by restarting them. Core Monitor has the ability to automatically stop or restart itself, allowing a secondary or backup Core Monitor to take control of the system as primary. The components controlled by Core Monitor are Queue Manager, Operation Mode Server, Provider, and Report Writer. Core Monitor ensures that only one queue manager is active at any given time using specific startup parameters. Peripheral Monitor can be deployed in an N+1 configuration given the requirements of the solution. Much like Core Monitor, Peripheral Monitor is responsible for monitoring and controlling 7.x components and to prevent their unplanned downtime by restarting them or by restarting itself if the number of component restarts have exceeded its defined threshold. The components controlled by Peripheral Monitor are Message Bus, Queue Watch Client, Global Call RVR, and Outbound RVR. The Peripheral Monitor monitors and controls these components and ensures that before starting the components, there are an active queue monitor identified and its components are able to connect to the active queue manager. Peripheral Monitor will update VirtualHold registry settings, VHT_config database tables, and XML configuration files. This is to reconfigure its components to connect to the active queue manager in an HA deployment. As stated previously, in version 8.0 delivers the first utilization of Erlang programming language. This allows the use of Amnesia, which is a distributed data store technology built within the Erlang development platform. Amnesia data stores are used to store and sync two different types of data within VirtualHold Suite. That is the current callback and user data and the component status data. Amnesia stores this data in two ways. The first is in memory. Amnesia will hold the data in memory, providing a near instantaneous synchronization between other Erlang applications within the data store cluster. The second portion, Amnesia writes the data to disk for persistence in the case of a failure or restart. Amnesia data stores are deployed both on core and management instances, which is used by each data store component. These data stores are responsible for storing and syncing queue managers, current callback, and user data. Queue manager receives this data when initialized. VirtualHold stores copies of this callback and user data in the following location. See program files, x86, VirtualHold technology, data store files. The notification server is a new component to version 8.x that does not run any version 7 components. Notification server is installed with each management instance. Its responsibility is to receive status messages from the core monitor and peripheral monitor as they manage their components. Notification server uses Amnesia to ensure the messages are kept in sync with all notification servers and management APIs deployed within a solution. This is to deliver component status data requested by the system management user interface. Notification server is designed to support being deployed in multiple management instances, identifying itself amongst other Erlang components. The first notification server to start becomes the active notification server, handling all component status messages. Any additional servers that will start function in standby mode. The management API, much like the notification server, does not run any 7x components and comes installed with each management interface or instance. The management API is responsible for delivering the component status data requested by the system management user interface. Each instance is a management API. A notification server uses Amnesia to synchronize data throughout the data store cluster. This allows requests to any of the management APIs from the system management user interface. New to VirtualHold 8.0 is the functionality of warm standby and system management interface. This allows customers to deploy redundant instances of VirtualHold software to improve upon uptime and increase fault tolerance. Each VirtualHold instance or core is aware of the other instance states via the use of Amnesia data store synchronization. Operating in primary or backup mode, the backup takes over as primary in the event of a failure. The two cores share their lists of pending ASAP and scheduled callback requests as well, so that no customer callback requests are lost if a failure takes place. The warm standby feature also includes a new web-based system management dashboard that allows administrators to view the state of each process within VirtualHold. So as you can see here, there's two core instances, each having their own op mode, report writer provider, and core monitor service, and queue manager. In a standalone situation, there would only be one core instance running, handling calls. In the warm standby or HA solution, they synchronize data via an HA link and connections via the Amnesia data stores to ensure that if a failure happens or if you request a failover scenario, that the other core is able to take over. New as well is the Launchpad UI. This is a web-based application for monitoring and managing the system in the 7.x release, but is now accessible through a single page called Launchpad. Users sign into VirtualHold system, and Launchpad allows selection of the application via widgets linking to the desired page. Applications currently available through Launchpad are dashboards, IQ, and system management. Dashboards provide a real-time view of VirtualHold environment and call statistics. Dashboards present the same information that had been available previously in QStats interface, but is now easier to understand and faster to navigate. Dashboards also provide the ability to create as many perspectives as you like. This allows easy switching between groups of queues that you care most about. The system management interface is a web-based user interface that provides greater ease of overall configuration and management of the multiple instances of VirtualHold. This will allow administrators to view the state of all processes, individually start and stop instance service, monitors, and other components. It also provides full control over the failover to backup or standalone process. The first step in knowing how to troubleshoot VirtualHold instances is to understand how the software integrates with your Genesis environment. In this section, we will identify the Genesis components involved in a Genesis VHT deployment and review the call flow of inbound callback requests and outbound callbacks. VirtualHold integrates with SIP server utilizing TLib or PSDK. With this connection, VirtualHold receives all CTI events as calls arrive and pass through the VirtualHold subroutine and target agents. CTI events are critical for the VHT queue manager to calculate an accurate EWT and also help determine when a requested callback should be initiated. GBP provides voice treatment for VirtualHold's Viz application. From the URL passed from a URS variable, GBP fetches pages from a VXML server. This provides the caller with the current EWT and callback options. Additionally, VHT will utilize GVP to launch all callbacks utilizing the SSG. This will provide GVP with the callback number. Once GVP receives a positive voice detection, GVP will then fetch the outbound Viz application based on the URL it receives from URS or ORS. The SSG virtual hold uses this for the outbound RVR component, and it passes the callback information to SSG via an HTTP post request. SSG takes this request and generates a make predictive call request to SIP server to trigger the outbound call. All progress detection results are also returned to the outbound IVR via SSG. The VXML server. VHT requires the VXML server to be Java-based web server like Tomcat. Viz application is deployed via a WAR file. When GVP fetches Viz pages, SOAP requests are sent via URS or ORS to the platform toolkit to pull queue stats from the queue manager and pass that data to VHT or to GVP. VHT requires Viz application to reside on an external server from the VHT queue management server. URS or ORS. In order for virtual hold to track the calls that arrive in queue, the VHT subroutine is required to be inserted into the existing URS or ORS strategy or workflow. Subroutine is used to determine the treatment for each call, and virtual hold monitors and passes the inbound URL to GVP to initiate the call treatment. The strategy or workflow is also used to provide increased priority of transferred callbacks before targeting the next available agent. Here's an overview of the components and how virtual hold integrates with Genesis. As you can see, there's TLib messaging that happens between SIP server, URS, or ORS, and queue manager monitoring those TLib messages happening on the SIP server. You can see the SOAP request that comes through URS to the platform toolkit, which is housed on your IIS server, as well as the SOAP request that updates the Viz server that handles all the call data that's passed to MCP via VXML. There's no changes to the call flow between 7x and 8.x. Here's a call flow example of a callback request. A new call will arrive on the voice gateway. A SIP invite will be sent via route point to SIP server. A route request is sent to URS or ORS, and a URS strategy or an ORS workflow is executed. The call will enter the VHT subroutine. URS will then send a get offer decision request to VirtualHold's platform toolkit. VHT will validate the current queue conditions. That would be the operation mode, turn on thresholds. VirtualHold will then respond with a VH offer equals yes. The call reaches a play application block, and a request apply treatment is sent to SIP server to request an MCP request MCP from a resource manager. SIP server initiates the call to MCP, and MCP fetches the VXML pages from the VHT Viz server. Viz will then send a request to VHT for EWT, or estimated wait time. The segment of the call is then passed as a part of this request. VHT evaluates the queue conditions and responds with the request with the current EWT. Viz then sends a request to create an interaction on the VHT queue manager. VHT responds with the interaction ID for the call. The caller is then greeted with the virtual call flow, is quoted the estimated wait time, and offered the following options. They can press 1 to receive a callback, press 2 to further options in the menu, press 3 to remain on hold, or press 4 to schedule a callback at a later time. The caller will then choose to receive a callback in this scenario. The caller's telephone number will be requested and collected via DTMF. The caller's name will be requested and stored in the Viz server. Viz then sends a request to VHT queue manager to create a callback record for that call. And VHT will create a callback and respond to that callback with that it was created successfully. The caller is then disconnected, and VHT tracks the caller's position in queue. Here's an example of a callback scenario where VHT will determine that a callback is next to be answered. The VHT queue manager will issue a make callback to the VHT outbound IVR. The outbound IVR sends an HTTP post with all the callback information to SSG. The SSG will then send a TMake predictive call to the Genesis SIP server. Call legs are established and the callback is placed to the caller. Once the caller successfully answers the callback, a voice disposition is passed to GDP indicating a successful answer. The VHT viz URL is pulled from the IVR profile and fetches the VHT viz application. VHT associates the inbound call record with the outbound external tracking ID in response to the request. Using the voice XML, the caller is greeted by virtual hold application and offered the following options. They can press 1 to transfer to queue, press 2 to receive more time for the caller on the line, and press 9 to cancel the callback request. In this scenario, the caller would press 1 to transfer to queue. At that time, a request is sent to VHT through Viz, indicating the caller desires to be transferred. VHT changes the call state to about to queue, and VHT responds to the request instructing GDP to transfer the call to the SIP server route point. GDP will then send a SIP refer to SIP server, and the URS strategy will then be executed. The call will enter the subroutine where the priority of the call is increased before exiting, and targeting the agent VQ. The call will then queue for the agent. Prior to queuing, the priority of the call will be increased. SIP server will send VHT an event queued message. VHT will change the call state to queue, and the customer will then hear music and queuing treatments. Once the agent becomes available, SIP server will send an event diverted message to virtual hold. Virtual hold will change the call to answered and clean up the call, and the call is then diverted to the agent. Now that we have covered the components involved and we have an understanding of the call flows, we can now focus on what data is required to identify and troubleshoot issues from a virtual hold perspective. Firstly, we'll cover log collecting. Virtual hold by default stores all of its logs in the installed directory. Traditionally, virtual hold will only store logs for 7 days. Virtual hold has an archive service that will archive data as it ages over those 7 days. By the 7th day, that data is rolled over to preserve disk space on the server. This default configuration can be changed depending on the customer's needs and available storage. By default, the logs can be found in C program files, virtual hold technology, VH logs archives for your archive files, and C program files x86 virtual hold technology VH logs for your active logs. In the event the customer has changed the default location of the log directory, this can be identified by going into the Windows registry and locating the following registry entry: HKey local machine software WOW 6432 node virtual hold. The string values that have the location listed will be under VHQ MWS provider log file path. The folders where logs are stored and organized and named by date to which the application is started. For an example, if the virtual hold application was started this morning, all the active logs for virtual hold will be in a folder called 2015_08_11. This information can be useful when troubleshooting an issue, as this will indicate the uptime for the virtual hold system. It is a good practice when Genesis support is requesting logs from a customer for virtual hold issues to request all available logs located in the VH logs directory. And any archive logs marked with a timestamp at least 1 hour prior to the issue to ensure you capture the start of the issue in the logs. Secondly, we'll be covering final fate codes. Final fate codes are used to illustrate the result of each call from a virtual hold's perspective at the completion of the transaction. These fate codes are logged in a queue dump table of the VHT_RPT database and are represented by a queue prefix and a number ranging 0 to 47. Each fate code identifies a specific result of that call. A few examples are Q3, which is a choose, hold, transfer to queue, where the caller will choose hold by selecting the hold option or by selecting a max number of invalid options. Q12 is an under threshold call. That's where the caller went directly to queue as EWT did not exceed the turn on threshold. Q13 is a route failure. The call failed and routed to queue, or the max holding threshold had been breached. For a full list of fake codes, they're documented in the virtual hold deployment guides. Final fake queries. Final fake queries in the database provide the ability to perform health checks against the system, as well as the ability to troubleshoot problematic calls in varying granularities, thus allowing you to do lookups on hours, days, weeks, etc. Additional information provided by the queries of a queue dump table show useful details for troubleshooting issues on the Genesis side as well. This provides such information as call IDs, ANIs, start and end times. This can be used in tandem with virtual hold's main output and main report logs to identify Genesis con IDs to track calls within Genesis. Here's an example showing the available data provided by a query of the first 1,000 entries of the queue dump table. Given your competency with SQL scripting, you can customize scripts to manipulate this data as it fits your needs. A few months ago, we had the opportunity to travel to Akron, Ohio to meet some of the virtual hold team and for a knowledge exchange between Genesis and virtual hold. During this time, we were able to review a few of the most common issues that customers faced. First example here is dealing with stuck calls. The normal symptoms of a stuck call is an elevated EWT. To resolve stuck calls, you would simply log into Launchpad, select Other Configuration in IQ. In IQ, select Settings and check the operational mode box and change the value from normal to shutdown. Once it goes into shutdown mode, you would change it back into normal. This should clear out the stuck call. To diagnose the stuck call, run a final fake query and look for a Q27 or Q35. This will indicate the system had identified and flushed a stuck call. Another example of a common issue that virtual hold finds would be that the QStats user interface is not populating data. A symptom of this, of course, is that the QStatistics interface is showing a 0 value. To resolve this, start or restart the QWatch client. This will, to effectively troubleshoot this issue, you must ensure that virtual hold is online and that the QWatch client is running. The last issue I have here today, which is specific to 8.x, is not being able to log into Launchpad, which is new to the 8.x platform. When a user logs into Launchpad, they will be prompted to enter a username and password twice. The user will then be sent to the IQ user interface and will be prompted with a message that says, "You currently aren't able to log into our new Launchpad application." When selecting the Learn More icon, you will be presented with the error in this description. Troubleshooting this issue, you should review the NT services and ensure that all required services have been started. The VHT authorization service controls the authentication of registered users in the system. And to resolve this issue, you would start or restart the VHT authorization service. And from there, you would be able to log in. This will conclude the presentation portion of this tutorial. Finally, before we start question and answer session, I'd like to mention a few other resources that are available to customers and partners. If you wish to further your understanding of virtual hold, they provide access to functional documentation and software downloads. You must register to the following links. For additional review of Genesis functionality, please visit the Genesis knowledge base to access a variety of information about Genesis products, including how to solve problems. The next available tutorial will be tutorial 88, and that's troubleshooting Genesis web engagement. and that's on September 16th, 2015. Register for the upcoming tutorials via the customer care website that's presented below.
Thank you, Michael. Just a reminder, when you exit the webinar, a brief survey will be displayed in your web browser. Thank you for taking a minute to complete the survey. Genesis uses feedback to improve our tech tutorials. And now let's start our Q&A session. Please click the hand icon on the meeting screen next to your name, and I will unmute your phone lines. Or you can type a question in the question chat window. We have a question on the line of Bernard Stroff. Go ahead, sir. He's not available. Let's open line for Ashok Nanda. Go ahead, sir.
Yeah, Michael. So in this one, which component is it's going to take care of the playing the Vox file? For example, if in the inbound subroutine, we'll collect the names as a Vox file and we'll save it, right? And again, when we're going for the outbound, we'll play the name of the customer and we'll take the confirmation. And who's going to take care of that here? Where that Vox file will be saved?
So the Vox file is saved in the Viz application and is played by MCP when the request a callback happens. So once the callback is received from, it was recorded by MCP and stored in the Viz application, and then when the callback happens, Virtual Hold will provide confirmation giving your name, asking if this is, and they'll play the Vox file of your recorded name and ask you to confirm if that's who you are. But it's stored within the Viz server and then played by MCP.
Okay, so in that point, so first it will play the Vox file, then only the call will be routed to URS control route line to talk to the agent.
Correct. Once the customer has selected one, confirming that is who they are, they'll be transferred to the URS strategy and then to execute priority.
Pick up outbound IVR profile.
So the outbound IVR profile is actually initiated prior to that, but it's once the MCP is actually involved in the IVR, that's when it will pull the Vox file for the user.
Okay. So previous to 8, the 7.6, the inbound was using a legacy GVP, right? So in this one, inbound and outbound both will be using NGI, right?
In this scenario, yes, but 8.x does support legacy GVPI as well. It just wasn't covered as more people are moving towards SIP deployments.
Okay, so still it covers the legacy as well.
Yes, so it's still supported by virtual.
Okay, so one last question in the license point of view. So what are the additional licenses I should be doing? Because this one you'll be using our GP for the playing prompts and all, right? So what is any other special license I need to take it further than the VST one?
Virtual Hold will provide a license specific to their component requirements. I believe that license is, if you purchase through Genesis, that license is provided through Genesis as well.
Okay, in our Genesis environment licenses, for example, it will be using to play the applications and it will be using a GVP ports, right? So the port level licenses, we need to put something extra rather than our normal count.
Sorry, can you repeat that?
See, in the GEP port license level, for example, it's whenever you do, it needs to execute that inbound IVR application or outbound IVR application. It will be using our NCP port, right? So for that, we need to which one it will be utilizing? The
I
GEP
believe
port
it's.
existing licenses.
I believe it will use existing licenses for GBP. I believe the new addition for licenses for virtual hold are specific to the functionality of the virtual software itself.
Okay, so for example, if I'm adding this one, I have a, let's just take example, I have 100, I'm expecting 100 call. So as per the plan, I put 100 IVR ports, I bought it. So if I'm going for the VST, so I should be adding 50 or 100 extra ports, right? I need to buy, just like example, I need to buy 100 extra ports.
Yeah, for any additional capacity, you would have to buy additional ports to be able to serve.
Okay, okay. Because whenever we want to play normal prompts via media server, we will not be using any. That will not need access any licenses, right? So it will goes via media server, or how it is gonna take this one, the license point of view.
I believe it goes the way of the media server, but I don't know 100% on that, but I believe it goes the way of the media server.
Okay, because usually it goes via the normal prompts, and it goes via that doesn't takes IVR port licenses, right? It takes the SDN licenses. That's why I just want to make sure in this license point of view, because I'm just working on one proposal. That's why I'm just trying to gather an idea on this one.
Sure.
Sure. That's it from my end. Thanks, Michael. Thank you so much.
No problem.
One more time, if you would like to ask a question, please click hand next to your name, hand icon next to your name. Michael, there are a few questions in the chat window. If you'd like, you can.
Yeah, I see one there at the bottom that actually was made mention. They are looking to provide at least the Viz functionality on a Linux platform. I'm not sure if that is currently available or what release that will be available on, but they are looking to utilize, at least from the Viz perspective, to be able to handle or to be able to support Linux servers for that portion. I think this, I'm not sure if this was answered prior, but there's a question around the two core instances are defined by primary and backup. Do each have their own databases defined? And does the failover occur automatically if the manual intervention is required for failover? So each instance will have its own virtual hold database. That would be the VHT config database and the VHT report database, along with their own individual data store databases as well. So what will happen is that each will have their own configuration, and the Amnesia database will actually update the data stores from depending on which one is primary and which one is standby or secondary. That information is passed back and forth, and in the event of a failure, there's an HA link between the two core instances. So if one core goes down, there will be an automatic failover between one core to another. The primary core that fails will go down, and the backup will come back up in a standalone instance. And that's done automatically.
There is a question on the line of Ramaya 3VC. Go ahead.
Hi, this is Ramaya. Hello. I have few questions on the VHT database where we are facing few issues like trying to schedule.
We cannot hear you. Can you speak a little bit louder?
Hello. Hello.
We cannot hear you.
Hello.
Oh,
That's
now we can. That's better. Yeah.
Okay, so this is regarding the VHD database. Like particularly, I'm worried about automating the VHD reports so that the health checks would be reduced. So I'm just trying to access the database, and I learned that there is an IQ database, and I think it was not included in the session also. So can we have the access to the IQ database so that we can just directly get all the queries whichever the IQ report is using it, right? So the specific thing is we are looking for the transfer errors, like how the transfer errors are calculated in the unsuccessful calls when the VHD is transformed.
So what I provided before within the QDump table, that provides the final fates of when we actually receive a transfer error. There are many reasons or variables that will take place that could be virtual hold related or could be Genesis related in the event of a transfer error. As if there are transfer DNs that are involved, virtual hold may not be monitoring those transfer DNs, so they would not be aware of that, and that would, even though the transfer actually was successful, it may not be, the virtual hold wouldn't be aware of it, and it would transfer the error as well. I believe the information that you're looking for would be doing querying on the QDump table. That's within the virtual hold _ RPT database. That will give you a full list out. And they're also, the site I provided you, that Insight site, they have many options or many examples of SQL queries that you can run that will give you a full, that gives you the in time, the end time, and the time that the actual fate code was provided through virtual hold, as well as connection IDs and of the like, that you can actually go back and help you troubleshoot what actually happened during that transfer.
Thanks, Michael, but still, particularly on those transfer errors which we see in the return call summary with unsuccessful calls, we are not able to get it in the final fate codes. So I've used lots of combinations, but still the count in the database and the report are different. So there were quite a number of final fates. So I think there are around Q60s, right? So I did everything, so still it didn't work. So particularly on transfer errors, there is no kind of calculation provided in the deployment guide in VHD. So
yeah, I think that would probably have to be something that you may want to open up a ticket for to have investigated, because I'm not aware of those specifics or why they wouldn't be available in the fate codes that you've investigated on. So I think your best bet would be to open up a ticket with either through Genesis or through virtual hold, depending on who you bought virtual hold through.
Okay, thank you.
No problem. Let's see here. I see a few more questions.
We have more questions on the chat, yes, if you can check them out.
Sure. As for the sharing a copy of the presentation, I believe in a week's time this will be available for viewing. I think a copy of the presentation, as well as chat questions and answers should be available to you.
Yes, it will be available in about a week. Everybody will receive a link to the recorded test tutorials, and it will include recording, PowerPoint presentation, and a Q&A log.
There's another question here around scheduled callbacks. Has anything been done about the time zone? Has been prompted to ask a caller what time zone they're calling from, VHD to calculate correct callback time. I believe currently they are looking into this, but I believe it's still, they have to specifically, I think it's specifically set time zones, as well as holiday schedules, and whether or not they follow daylight savings time. any more information that I'd have to go back to virtual hold to get some more specifics on that. Another question here is how hard migrating from 7.6 to 8.x is. This would definitely depend on the complexity of your environment. It would depend on how many queues you're monitoring. A lot of the 7x components are still present, so a lot of your configuration would stay the same. But I believe a full uninstall of 7.6 and a complete install of 8.x are required. I believe that they provide services that give functionality to or provide assistance with the migration from 7x to 8.x. So I think it would be in good interest to contact them to have them ensure that your migration is done successfully and you're successfully able to handle calls. Does 8.x support Oracle? I do not believe that they support Oracle. I believe it's only MS SQL with the Windows environment for as virtual hold is as a software is deployed outside of the Viz server is built around a Windows environment. I don't believe that they support Oracle at this time. Another question here. Question about scheduled callbacks. They have to create a KVP to perform a data dip to the config database. And the area code for the area code offset. Does this offset go to the Viz to be played back to the caller? I do not know, to be honest with you. I'm not aware if that functionality is present. That would likely have to be a ticket that would have to be opened with virtual hold to get specifics around whether or not that functionality is either available or could be available via feature request. Let's see here. In the new version, do virtual hold have the availability or visibility on agents' availability? I believe that still they have no integration with stat server, so I don't believe they have that much visibility other than what's provided to them via ORS or URS. To answer your question. I think the last question that I see here, the prevailing issue in the blended skills scenario, has that been resolved in the newer version? I am not aware if they've provided any additional functionality around blended skills or targeting specific skills where an agent has a multiple skill set. I've heard in conversations that that is a pain point. But I am not aware of any resolution of that issue in the 8.x versions.
So no more questions to answer, right?
I think that's it.
Okay, if you'd like to ask a question, please click on hand icon next to your name or ask a question to our chat window. Okay. At this time, we have no more questions. Thank you, Michael, for sharing this information. Thank you, everyone, for attending. We will look forward to seeing you on our next Genesys Customer Care Tech tutorials. And just as a reminder, you will receive a link to recorded tech tutorials in about a week. Thank you, everybody.